When Venus passes in front of the sun, what kind of science can be gained now that you couldn't gain 8 years ago about Venus's atmosphere?
Well, in just 8 years, the technologies of instruments that we have to look at planets, including just the refurbished Hubble Space Telescope, is in a different state. And so the network of observatories on the Earth, just the networking available through the World Wide Web, through the internet, the satellites we have, including a European Space Agency satellite that's in orbit around Venus, the Venus Express, built by our friends in the European Space Agency, that together with this much more integrated network of observers that can talk to each other through community social media mechanisms for science, allows us to collect more data to look at some very fundamental numbers which were first discovered and measured 100, 200 years ago. And again, I see this transit of Venus as symbolic of where we were, more than a century ago, to where we're going with spacecraft that can interrogate these other worlds, even someday around other suns.
Tell me about the different layers of the atmosphere of Venus and what can survive and what can't.
So Venus has one of the biggest atmospheres of any rocky planet in the solar system. In fact, if you compare the atmospheres of Mars, Earth, and Venus, you go Mars, little, cold. Earth, big, nice, we live there. Venus, gigantic, massive compared to Earth's. It's a swirling maelstrom of chemistry, winds, and dynamics, all of which we really don't understand. So as you start at the top of the atmosphere, you start to hit molecules such as carbon dioxide, escaping hydrogen, and other trace elements. As you move down, you'll hit a dense cloud deck on Venus that starts somewhere between 40 and 45 kilometers, extends up to about 60 kilometers above the surface. That's 180,000, 200,000 feet, much higher than the clouds on Earth that we know and love. That cloud layer, that multi-deck cloud layer, is made up of chemistries that involve sulfuric acid, something that's extremely caustic, not something our spacecraft like. Balloons don't like it. Parachutes don't like it. And then once you get to about 30, 35 kilometers above the surface of Venus, the average surface, the atmosphere clears. And all the way from there down to that extremely hot surface, it's clear. In fact, as you fly, you're limited in what you can see below the clouds by the refraction of this extremely dense CO2 atmosphere. And it's so dense that we measure the density of the surface of the atmosphere near the surface of Venus is only about 10 times less dense than liquid water. The carbon dioxide down there is actually a supercritical fluid, something very different than we're used to here on Earth. So from Venus, as you peel the onion, you get denser, deeper, hotter very quickly. And you go from the cloud deck, roughly the temperature you'd have in the low altitude clouds here on Earth, to the surface where it's 450 degrees centigrade. Wild and woolly stuff.
Volcanoes on top of a surface that's so hot, that just seems to be extreme.
Well, on Venus, we've actually, from the Magellan mission, we've seen evidence of landforms that remind us of the big volcanoes we have in Hawaii, the big ones on Mars. We see vast rolling plains, which look to be like those that could have been formed by the massive flooding of lavas, like we think happened on places on Mars, probably in early Earth. So we see a very likely volcanic Venus. And recent work by scientists here in the United States at JPL and other places suggests that there could be some volcanoes that are active now, actively erupting, even in this hot, crazy planet we know of Venus. If that's happening, Venus may be one of only 3 places where we see active volcanism of the kind we have on Earth. The Earth, of course, Io, the big moon of Jupiter, and of course Venus. Now we have other kinds of things going on at Enceladus, out at Neptune's moon Triton, but again, these are the kinds of volcanic processes that we know on Earth, critical on Earth, they could be happening now on Venus.
How long will we be able to feed off of the information we gain during this next transit of Venus, which will be the last in our lifetime?
Well, this transit of Venus is particularly important because, A, it reminds us how far we've come out of the astronomical age into the space age. This is one at the peak of our current capabilities, 50 plus years into the history of NASA, and it reminds us what it might be like 100 plus years from now when another generation, another group of people, hopefully, continue exploring our sister world. So what we'll gain from it is the perspective, again, reminding us what is unknown about our sister planet. What is it about transits of planets in front of the sun? And remember, only Venus and Mercury do that from our perspective on Earth, of course, because they're inside the Earth's orbit relative to the sun. What we can learn from that technique as we look out beyond our solar system at other planets around other suns. And that's one of the new fields in astrophysics, taking a census of the exoplanets of our universe. are there other pale blue dots like our own priceless world, or orange white dots like Venus, for that matter? And that's one of the kind of fundamental questions. How small and interesting can planets get that still sort of behave as big rocky planets like Earth and Venus? Because we're sisters and brothers, right. Earth and Venus. Mm-hmm. No other planets are in, rocky planets are in the same size domain as Earth and Venus. So it's really important to leverage what we can learn from our sister planet.